In this section, we solve rational inequality. We have three inequalities that we are going to solve. Let's start with number one. The first thing I do, I want to have a fraction in one side and 0 in the other side. That's the key. So that means for me to have that, I have 2 minus x. I have to take this expression here and put them in the other side. It's positive becomes negative, less 0, because nothing is left there. From here, now I can just, to have just one big fraction. So what I'm gonna do is, I can just multiply x minus 2, and divide also by x, because I can cancel and it still gives me x minus 2. Minus 8 over x has to be less than 0. Then I have that x squared minus 2x dividing x minus 8 dividing x less than 0. From here, I have as a fraction x, so I just I have in the denominator x, so I just maintain the x and I add the numerator, so less of 0. So I have this inequality. So from here, I can just solve this equation. So before I solve it, I see that actually this expression top, I can actually use factorization. So I'm gonna have x. I do this as in the previous video. I have x squared, x times x, and I have 8. 8 is 2 times 4. I want to have a minus 2 here. That means I have to have minus 4 plus 2, right? So minus 4 plus 2 has to be less of 0. Now, from here, what I do, I go to the table. This table is very important. Okay, the first one is the expression on top, which is x squared minus 2x minus 8. I use just this one, and we are going to see why. I use this one on top. The second expression is the denominator, is x. And then I just study the sign of the entire fraction, and it has to be negative to be less than 0. So here I just have the division. I have x squared minus 2x minus 8 dividing x. Now, from the top, I have x minus 4 and x plus 2. So that means I have x equal to 4, and I have x equal to minus 2. So I come here, minus infinity, and I organize in order. I have minus 2, and I have 4. I left a space because I knew that from the one on the bottom, I have x, right? X equal to 0. So x equal to 0 is the root of the expression at the bottom. I have to put them in order. First is minus 2, then 0, then 4. Okay. For this expression, when I plug minus 2, gives me 0. And when I plug 4, gives me 0 too. When I plug 0, does not give me 0. Okay. But when I plug 0 here in this expression, in the second one in this expression, gives me 0. Now what I'm going to do is, I start from here, in this direction. I come here. What is the sign of x squared? It's plus, right? It's plus, positive. So I put positive, and I start coming. I meet a 0, right? When I meet a 0, I flip the sign. Minus. I meet another 0 here, I flip the sign, plus. The same works here. I'm coming from here. What is the sign here? Is positive, right? Sign of x is positive. Positive. I meet a 0, I flip the sign, negative. Now I just need to do the operation to get the sign of the fraction. Plus dividing minus gives me minus. Minus with minus gives me plus. Plus with minus gives me minus. And plus with plus gives me plus. Now, okay, less than 0 has to be the minus here and here. Also, now I need to check. This sign does not say that it has to be equal. So that means these values like -2, 0, and 4, it's open. That means they are not included. So the solution will be just the interval from -infinity to -2, not here. Then I put a union with 0 until 4, open. So that's the solution for this first inequality. Let's solve the second inequality. This one, we already have 0 here. So what I'm gonna do is just solve x plus 4 has to be 0, x equal to -4. And x minus 1, 0, I just write x equal to 1. Then I just bring it here on the table. First I have x plus 4. Second I have x minus 1 minus infinity plus infinity, like that. So I have 1 and -1. I have to organize in increasing order. So -4 comes first, and then 1. Here I have x plus 4 dividing x minus 1. Now, when I put -4 in this expression, gives me 0. And when I place 1 to this expression, gives me 0. What is the sign of x? Is positive. I come in this direction. Positive, positive. I meet 0, right? I meet 0, I flip the sign, negative. Now here, what is the sign of x? It's positive. I come in this direction, positive. I meet a 0, so I flip the sign, negative, negative, until I meet a 0 again, then flip the sign, and so on. Now, for this fraction, I have just to study the sign. Positive, negative, positive. Like that. So less than 0, it's here. Negative numbers. Now, I have to study because it says has to be less or equal. That means the number of the numerator should also be included in the solution. The numerator is -4. Will be included. Here, for the 1, is not included. Why? Because if you include 1, it gives you 0 on the bottom. That means the solution is going to be -4 included until 1 not included. So that's the solution. Okay, now let's solve the last inequality. The key is to have the fraction one side and 0 to the other side. So that means I'm going to have x plus 3 divided by x plus 1 minus x minus 2 divided by x minus 3 has to be greater or equal than 0. Now here, what I do, I want to have the same denominator. I can just use the same rule I used previously, multiply this by that and this by the other one, and then you do it like whatever way you think is the best for you. So what I'm gonna do, I have to have the same denominator. So what I'm gonna do is x minus 3, x plus 3, divided by x minus 3, x plus 1. It's still the same, right? Because I can cancel x minus 3, so it's still the same. Minus, here, I'm gonna do x plus 3 multiply x minus 2 dividing x plus 3 that multiplies x minus 3. Sorry, x plus 1 that multiplies x minus 3 has to be greater or equal than 0. Here, we can see that we have the same denominator. We have x minus 3 and x plus 1. Now, the one on top, I can do the multiplication already. X plus x, x squared, plus 3x, minus 3x, and then I have minus 9. Minus, here I have x squared, minus 2x, plus x, minus 2. Greater or equal than 0. Then I have x squared minus 6x. Oh, sorry, this is 0. So here it's 0. So minus 9 minus x squared minus x minus 2 divided by x minus 3 and x plus 1. 0 like that. Okay, then I have that x squared minus 9 minus x squared plus x plus 2 divided by x minus 3, x plus 1 has to be greater than or equal to 0. This, I cancel this, then I have x minus 7 dividing by x minus 3, x plus 1, 0. Now, from here, it's the same thing of the table. So I have x minus 7, 0, x equal to 7. X minus 3, 0, x equal to 3, and x minus 1 equal to 0, x equal to minus 1. But I know that the numbers in the denominator, they are not included in the domain. Just be aware of that. Now I come in the table. I have on top x minus 7, and I have at the bottom x minus 3 that multiply x plus 1 minus infinity. Then you have, now I have to organize infinity. Here is x minus 7 divided by x minus 3 times x plus 1. Now I have to organize. I have x equal to 7, x equal to 3, x equal to minus 1. So first minus 1, then 3, then 7. 7 gives me 0 here. 3 gives me 0 here. Minus 1 gives me 0 here. So the sign of x here, it's positive, right? So I come here, positive. I meet a 0, flip the sign. Like that. So here, the second one, here, if you do the multiplication, the x squared, the highest order, is going to be positive. So from here, positive, positive, I meet a 0, I flip the sign. I meet 0 again, I flip the sign. Now the sign for the whole expression is going to be negative, positive, negative, and positive. So here has to be greater than 0. Greater is here and here. And remember that the numbers on the bottom are not included. That means the 3 is open and the minus 1 open. It has to be greater or equal to 0. That means the one on top is included. It's closed, is included, because it gives me 0. 0 is included. So that means I have the solution minus 1 open until 3. Not here, that means I place union with 7 is closed, is included until infinity. And that's the general solution. That's how you deal with rational inequalities.